Welcome, students. I'm going to go through a data set top to bottom, similar to the way that you would in your projects. Now, there's only so much that I can do in half an hour, but I will do what I can. This is going to be a review of many of the concepts that we've covered and possibly a couple of new things. So let's dive right in. Open up a new Colab notebook. Always you are coding with me. And go ahead and copy in the URL that has been provided to you and look at the first 5 rows. Okay? This was brand new at the beginning of our session. And, well, let's just say I bet you got it down by now. So pd.read_CSV, put in that URL and examine the first 5 rows. And this is the Portuguese student data set from UCI Machine Learning Repository. Oh my goodness, what is going on here? This does not look right. So let me just show you that. Do you see the semicolons here? So comma separated value, CSV stands for comma separated value, meaning commas are in fact separating the text. Well, in this case, it's semicolons, so you can't actually make a specification here calling the separator equal to, in quotes, semicolon instead of comma. So go ahead and try that. And then you see it works as it should. Okay, just quick looking at the data set. Oh, by the way, in terms of doing this properly, the text comments should come often. So if this is the data set we're going to analyze, let's quickly set it up. It's Portuguese student data. Change that later, perhaps. And then, you want to have like different headers. And so the first header, this could be like your first group, which is basically something like, not just loading, but I mean, you could call it loading, I guess. Because we're not just going to load it, we're going to comment on it and look at it. Examining data might be better. I like that. Examining data. Okay. So, and then again, I'm not going to do all the text comments, but you would put one here, for instance. This is the idea of having a complete notebook. You would say something like, talk about your data. This data set was taken from the UCI Machine Learning Repository. You could provide a link. Displays information and grades for Portuguese students. Okay, you don't need to write an essay, just give a little info. Okay, and do at least one comment per coding block. So load data. Sometimes this is called the student data. Okay, so now it's been loaded. Now let's make a brief comment on it with the text cell. And so you could say something like this. There are multiple columns of interest. And yeah, maybe highlight a couple, right? It's like they could all be interesting. And I'll just say including study time, travel time, and grades. Those are the ones at the end. G1, G2, G3. Okay, now I don't expect you to keep up with all of my text comments today. Okay, that's not the point here. The point here is simply that when you're going through your data, you should be adding little comments about it, okay? Show us that you're interpreting it. Show other people. They can be very brief, okay? Okay, I think it's, you could also include, I think it's important to include df.info. And again, you would want to add little comments before and after. Now, this is all non-null values, okay? So this is great. It also reveals a lot of strings, though. All right, so comment on the code. There are no values, but quite a few string columns. And note those are called object that must be converted for machine learning. Now, it doesn't have to be converted here, okay? And when I say that, because when you do like histograms, you know, you can have like yes, no can be more, and male, female can be more indicative than 0, 1, okay? So that can actually come later. Okay, let's do a couple of histograms, all right? So that would be a new text header, histograms. And then, okay, I'm not going to copy the code. I'm just going to quickly go for it. If in your case, you might want to copy it, you know, if it's, hey, we've already got good histogram code. Import matplotlib.py plus plt. Import seaborn as sns, sns.set, plt.figure, fig size equals 11.6. And then what else do we got? We can just go ahead and do it. plt.hist. Now, what am I going to do a histogram of, right? Well, what do I want to see the distribution of? That's the key. I like the grades. There's G in there. G1, like let's check the grade distribution, right? So let's give that maybe the title, grade distribution. Title it that. We can show it initially to see what it looks like, and then to see what kind of changes we want to make. You know, like do we need? I think we do need an X and Y. We should look up seaborn histograms. Okay, it's pretty symmetric, right? I mean, that's a legitimate, like, you know, solid histogram that you could use. Now here's the thing. When you're completing a Colab notebook, that's fine. You don't need to like export it. But when it comes to Google Slides, which is what the final project is going to be, you want to export those beautiful graphs, okay? Because it's going to look much better. By the way, these do not have an X and a Y, so I think you definitely want to include those in your histograms. plt.x label would be grades. You can be more specific. It's a certain period. G1 grades. And then plt.y label can just be count. Right, that's the number of people. And again, you would make a comment, and your comment could be something like, you talk about the distribution, okay? The distribution of grades is symmetric. And then look at the peak. What is the peak? The peak looks like it's just after 10, okay? With a peak of, looks like, say between 10 and 12. 10 to 12. And by the way, grades, these are like, in Portugal, my understanding is that this is like A, B, C, D, F, okay? This is not like, oh, the most students are in the 10th grade, right? No, you would expect a kind of a uniform distribution there. These are the grades that they earn. So, you know, maybe that's like a C for us. I'm not sure. Okay. So, and again, but with your own data set, your own project, you would want to look up that type of information and put it in there, right? The more info that you present, the better your project is going to be. Okay, so there's a histogram. I'm only going to do one, right? I'm not going to do a bunch of histograms, but just to show you, don't forget, for in preparation of Google Slides, go ahead and do the save fig, right? plt.savefig with your title, and then excuse me, DPI, thank you. DPI is about 200, right? And recall that what that does, it opens it up on the left, grade distribution. I can download it then and you know, get a cleaner look. Again, this is what you would use in the Google slide. There it is. looks a lot nicer on my computer. Okay, and I would be satisfied with that one as is. Now you do see some of these low values too, down by 0 more clearly. Okay, and if you wanted to change the color, by the way, don't forget, you can, within the histogram right here, you could do color equals, and you could pick whatever you want. And for grades, are they green? You know, good. I don't know. It's pretty good. And then don't forget alpha, you can get some transparency in there like this. 0.76. All right, looks kind of cool. Okay, if you have additional questions on histograms, ask in your cohorts, or look stuff up. Okay, you can look stuff up and often get things the way that you want them. Okay. All right, so now let's move to scatter plots. Okay, and again, I would do more of these. Okay, but I'm only doing one because I want to show you multiple things within our time frame. Okay, so how to scatter plots. Now I'm going to do something additional here. Okay, and I'll explain with the text. So now let's look at the relationship between columns, right? So we can look at how one column affects another. Well, there's a statistical technique called correlation, okay? And you can get it, by the way, with df.core. Will give you, I think it gives you the correlations of the whole data set. Let me try this. Yeah. So this is nice. Now, if you take like a row like G1, okay, and you see all these numbers, okay, the numbers that are closer to 1 have the highest correlation with G1. It's something like this. When we do a scatter plot, if like they make a perfect straight line, that's a correlation of 1.0. It almost never happens. If it's like really close to straight, like, it could be like 0.9. If it's like upward clear trend, 0.5, kind of middle-ish, 0.0 would be totally random, no relationship whatsoever. So in fact, it is a measure of linearity, okay? And if I look at this, well, this is 3.8 is actually pretty good. So what's that column? Failures. Well, that makes sense that your failures would be a big influence of your grades. What else do we have? 1.0. What's 1.0? Well, it's the same column, right? So CG1 input and output are the same. And certainly the other two grading periods are the other most highest, right? So if those are the best indicators of how well a student will perform are in fact, these two numbers, these two grades. So getting correlations, getting these numbers is actually a way to determine the relationship between two, okay? And I think it works also straight out with individual columns, okay? So if I want to focus on G1, like let's just pick something like study time, right? What is study time? You would think it would be high. Okay, I'll do it without, I think I see it up there, but, oh, by the way, negative means it would go down. Negative means as say G1 goes up, the other thing goes down. So if I try like df G1, and I want to get the correlation with, not sure if that's the right syntax, honestly. Df study time. It is the right syntax. So 0.26, so you can get the individual correlation. I would encourage you to do that with your scatter plots. It's more information. And again, just think, the closer to 1, the higher the linear relationship, okay? What does a 0.26 look like? Well, let's find out. We can do a scatter plot, okay? And again, if I'm making a complete notebook, I'm making comments about what I'm doing here. All right, so I can copy, well, remember we have that SNS scatter plot is better. I'm going to copy some of this info, though, to save time. trying to cover a lot in here, and put it in here, and now shift it. Now, if in a complete notebook, you don't necessarily have to like import everything again, okay? And we've been doing that because I want you to have all the code. But if I'm thinking, hey, this is a final notebook top to bottom, I don't need to do imports more than once. I think that there's a way, I believe, to set this in advance for all of it. I don't actually have it, but I know you do need to do it for each individual graph. So this is going to be sns.scatter, okay? sns.scatter plot, and then x equals dfg1. Wait, that's what we're trying to predict. That's how I like to think of it. You could really do it either way, but I like to think of it as what you're trying to predict is y. Okay. So y equals dfg1. And these are the types of things you would say. Like in this section, I'm looking at, how other columns can influence the grade. Okay, so we'll start as just a straight scatter plot, and then it's got a title of these things. You could call it, why not? Influence of grade distribution, influence of study time on grades. I believe Seaborn is going to give us these titles so we don't need them. Okay, let's try that. Okay, you can see they have, this is interesting. Wow, that's interesting, right? Why? Well, number one, there's only, looks like 1, 2, 3, 4 study times. Also, the correlation, I thought some of the correlation would be greater. I mean, if you look at the grades, you do see that if you look at the bottoms, at least, they do trend upwards, okay? So that's why you see the 0.26. And note that the scatter plot is a little bit limited because of the, that there are only 4 options. So recall that we can also add things like the hue. We can color it by something else. Like, let's see if travel time matters. And we can also use the size, right? The size of the dots. So what should we pick for size? Let's see. I don't know. Absences, maybe? I'd be curious to see how absences affects it. And so now this is kind of nice because we're getting, a lot more info in it. So let's try that. And not the most beautiful scatter plot here. Like the sizes, like the absences, do not seem to make much of a difference. Well, I say that, but it might have to do with the sizing, right? The sizing is probably too small. I have to go back and look up how to change the range of the sizes. And you have access to the previous videos. And I think like possibly different one may look better. Like I don't know. I mean, you could leave this one and then you could tell I'm not crazy about it, right? Oh, and I spelled influence wrong. Influence of study on grades. Study time. The color thing too, it's like we do see a variation in the colors, but they're there's not like a clear pattern that I can see. By the way, if you want to try something totally different, you could try like G1 here and G2 here. See what that looks like. Now see, see how that's a high correlation because there's most clearly a particular straight line that can go up there. Okay, you guys have the code. I don't have it in front of me. which is how do we change the sizing of this, okay? The sizing of the dots. It's different in Seaborn. But hey, that graph communicates interesting information. Okay, and I encourage you also to look at regression lines as well, which you can also include in your scatter plots. Okay. The next thing that I want to do is prepare this data set for machine learning. Okay, we're actually doing that this week. And so it needs two pieces. Okay, so this is important. So here we go. New text cell. It's going to be called prepare data for ML, short for machine learning. And this is all it is. To prepare data for machine learning, we need no null values and all numeric columns. Now I can add more, right? So I'm in a data set here. So this data set has no null values, but it has columns that are not numeric, that are non-numeric. These need to be transformed. And you can like guide the reader and say, we can use PD get dummies. Okay, so what's that going to look like? We've done it before, right? No big deal. So df equals pd.getDummies df. Now, do you see this drop first option? It's false. It's kind of interesting. So just to give you an example, when you have like classic setups like male, female, which is a bit, that's a bit traditional at this point. There are only two options. Do you really need a column for both males, which are all zeros and then ones, and then both female, which are also matching or complementary ones and zeros? No, you can use drop first equals true to eliminate that. However, it's not as ideal when you have like multiple options, okay, even though it can be inferred. So the default is false. I don't know. I tend to sometimes just leave it as is. So if we just leave it as is, let's check it out. So everything's numeric, right? And once you have the underscore, now you have the more info, because it's like school was a previous column. Now the school is either, it looks like only two options, GP or MS. Sex, only two options, F and M, female and male. This is what I mean. Like, you don't necessarily need both of them because the one like gives you full information about the other, right? So really, if all these are twos, you could do drop first. Now they're not all twos, right? You got M job and so on. And you could even break it down by columns and do it like that as well. So I'm going to leave it. And I could get the new info, or df.shape would be nice, right? How many columns do we have now? 59 columns. So, again, communicate with the user, right? What does this mean? The adjusted data frame has 649 rows and 59 columns. Okay. So I feel like that is the core piece. Okay. There's a lot more you want to do, but these are the core elements. So let me go back over it and highlight. What do? We examine the data, right? Open it up, look at it, talk about it. Does romantic mean are they in a romantic relationship? Look at your. I didn't do df. Oh yeah, I didn't do df.describe. I think that would be. You should always do that, honestly. So let me just add that in. This is why it's also helpful. You don't always get things like, oh, this is how I did it the first time. You want to go back, look at things multiple times and do them, do them correctly. Some of the work that you see me doing here is the first time. Some of it is not the first time. Okay, this is my first time doing this one quickly, top to bottom. But if I was going to publish this, I would take a lot more time. So let's do that one. Now this is interesting. So we just changed the data set, right? So if you do df.describe right now, you're going to get the new one, but you want the original, okay? Because this is where it comes in the kind of the data story, okay? You want to try to be telling a story with your data. So this is where this runtime, run before is useful, do that. And now, because it's stored from the top, it has the original df. The new df.describe. Now I can talk about also the distribution of data here, right? We've talked about this, right? Where now we can see that travel time is only between 1 and 4. So there are 4 different options. And we can get a sense of the number of failures based on this. Okay? And also the grade distributions, which we talked about. Remember how we were seeing that 10 average? Looks like 0.3 is the mean, and 10 that's 25 percentile. Yeah, so it looks like more like 11. So we get more information, or 11 is the median. So I'm not going to fill in that text information now, but you would want to do that also. Okay, second part is the graphs. Histograms show a few. People like visuals. They can see them, like you can just look at that in one sweeping glance and get a sense. Easier than the numbers, okay? So give them some histograms. Give them some scatter plots. Go back to the original video and, make them nice. I think this one would actually be fine, just changing the sizes is all. And the other piece is I encourage you to include correlations with it. Gives you more information. I encourage you to include regression lines with it to give more information. These are all covered in previous videos. Hopefully you've been doing this along the way. And then finally, you do need to prepare your data for machine learning. Now, in some cases, you should be clearing the null values initially because you can end up with blocks, histograms that won't run. Sometimes they will, sometimes they won't. I think it depends on the number of null values. So you do just want to make sure it is both no null values and non-numeric, okay? And when you do that, you're basically analyzing big data using pandas with Python, okay? And please keep in mind that what I present to you in this respect is almost like a beginning, okay? It's kind of like the first key steps, because what you need to do is ask and answer questions about big data and develop new skills in some cases to be able to do that, okay? Like in this particular data set, just give you an example. Like if I want to look at, like what's my question? My question could be something like, how influential are G1 grades and G2 and 3? Okay. What if that's a 0, means 0, if that's like a null value? And if that's the question that I'm asking, well, that's going to define what scatter plots I look at, what histograms I look at, okay? It could define a lot, it could define like, it's too bad that things like absences don't, they're not like given as like G1, G2, or G3, like different periods. So your data story ends up being fundamental, okay? Because if you just like throw out numbers and graphs, what does it mean? You need to have grounding as to what it means, to the point where I want to encourage everybody today to ask and answer a question with your data, okay? And that could be like the question I could put at the top even. Okay, it could be like even a thesis, right? Put in bold. How does one grading period influence the others? How strongly, how about? Bold. See, and then this defines each little part like this. You know, there are columns for 3 different grading periods. You see what I mean? So it's a slight change, but it's a big one. And it defines this whole thing to turn it into something that has a narrative, that has meaning. Just ask and answer a question, right? You're still like loading the data. You know, this is still fine. I mean, you could talk about it a little differently. You know, and when it comes to this, I mean, it makes sense. I think I did. Well, you would look at G1, right? And talk about it a little more. And that you would look at, say, you know, like you could, it's not that you exclude, you don't then say, well, hey, this one isn't as interesting because I'm not focused on that. No, by all means, it's interesting because, you know, you can look at how other columns affect them, right? That's important. It's there. You're not ignoring. Questions help you to focus, right? But this would be big then, right? Where we get a clear correlation here, right? And furthermore, see, you can do it with PLT actually. Print the correlation. And then when you do that, you see how it comes right there? See, that's adding information now on, well, it's on the output. I mean, it's not a part of the graph, but you know, you could make it a part of the graph. And you could also include, like, make it a little F string. Correlation between G1 and G2 is, put it in brackets, right? That's just a number. You gotta put it in between the right parentheses. And then maybe a period. Try that. Got an error. No surprise. Let's see. What did I get an error there? F, because I delete, now I got the F string in. Invalid syntax. Well, look, you could do it like this. Core equals, I thought I had that right. Let's try this. Now you see you're given more detail. The correlation between G1 and G2 is 0. You know. And so that's a strong linear correlation, okay? I encourage you to look up correlation. I'm not giving you guys a lecture on it. You can talk about it in your cohorts. If you just look it up, by the way, correlation, by the way, does not imply causation, and look up images. You know, these are nice. You can click on some images and see what different correlations look like. That's a little small, actually. That's a little bigger. See, large positive, medium positive. They're not giving you the numbers there. This one gives you the numbers. So you can start to get a sense, right? It's not the line, okay? It's how close the dots are to the line. So the closer the dots are to the line, the larger it is. It's a major topic because, okay, I'll end on this. Because if the question was simply in the relationship between G1 and G2, well, there's a numeric answer, 0.86. That's high, right? But it's quantitative, okay? It's got a quantitative answer. All right. I'm going to stop on that note. So that's an example of how you can take your data set in one notebook, top to bottom. And that's what I want you to do today to close out this week. Okay? You can work on it as all today and It'll give you a little bit of time. Well, take time on your own if you can over the weekend, and the final projects, this will be a part of your final project, okay? Basically starting our final project notebook. But this is one big piece, and it's, again, by no means is it the last day. You'll have plenty of other opportunities to kind of continue to refine and move forward with what you're doing. So keep up the great work.